So let's continue our studies of virtual alias maps because this is a great way to set up virtual domains within your environment. It's the preferred way in comparison to the basic virtual domains where all users have email addresses at all domains. We'll nano the virtual file because this is where we'll make our changes to the matrix. So again, we have two users defined as recipients for mail to the domain linuxcbt.external. But what would happen if an email is sent to a user who doesn't exist? So we do have definitions for the user Dean as well as for the user linuxcbt Susie1. But again, if we sent a message, let's say to the user linuxcbt Susie2, where would the message go? To illustrate the point, let's attempt to generate a message from linuxcbt work1, which is the Susie Pro system. So we'll use linuxcbt Susie2, a non-existing user, at linuxcbt.external. Let's see what happens with this message. Testing mail to a non-existent user. We'll send it, and this message hasn't bounced to us directly, but at the same time, on the server side, let's examine the result. We'll tail varlog mail, and we'll see where this message has been sent to. It's been rejected. Now, the reason why the message hasn't bounced to the mailbox of the user linuxcbt work1 is because we've altered the configuration, the postfix configuration, on linuxcbt work1 to the point where it's not accepting messages back. But there is evidence on the server side that the message was bounced. Just read the logs, and here's the connection from the system at a time that reflects closely to ours from root, and it was destined to a user who was unrecognized, so it was rejected. Recipient address rejected, user unknown in virtual alias table. This is a common area you'll find all over Google with many proposed fixes. Again, this user doesn't exist. But we have a quick fix for this. Let's nano the virtual file. Now, there are a few ways you can handle this. You can approach it from a regular expressions perspective, which postfix supports. It supports Perl-compatible regular expressions as well as basic regular expressions as defined by POSIX. But you can also define what's called a catch-all address, which is a very easy way of handling mail to addresses that are not defined or mailboxes that don't exist. The only problem with catch-all addresses is that it attracts a lot of spam and unwanted emails. So this is really just to show you that the feature is possible, that postfix will provide the mapping and route the messages accordingly, but it isn't necessarily recommended for a production environment because then any message destined to, or any unsolicited message, such as in UCE, destined to a non-existing user on the system will get routed into this catch-all box. Maybe it is desired in that you want to maintain evidence of messages that have traversed your system. So you may have catch-all mailboxes such as abuse, spam, and so on for catching these messages and storing them for your accounting and audit trail purposes. So to define a catch-all, simply specify the @ symbol, prefix it with the domain, so it's going to be at linuxcbt.external. So this simply says anything to the domain linuxcbt.external. It doesn't, of course, match what we've already defined. Send it to a given user's box. Now, this can be a local or a remote address. Let's start with local. We'll send it to the user's box, linuxcbt Susie1. So what this says is as follows. linuxcbt Susie1 will receive normal mail destined to linuxcbt Susie1. Also, any message to Dean will go to Dean. But anything else will go back to linuxcbt Susie1. And we could set up an abuse account. It could go there as well, but you get the picture. Now let's save it. We'll postmap the virtual file to update it. And then from linuxcbt work1, let's send a new message yet again to linuxcbt Susie2, again, at linuxcbt.external. Let's just verify that our map says external, and it does. So we're sending it to external, testing catch-all address. We'll ignore the body and send the message. Again, you won't see bounces until we alter the configuration on the professional box. Now on the server side, let's tail var log mail to see what has transpired, to whose mailbox the message was delivered. And as you can see, the message originally sent to Linux CBT SUSE 2 got redirected to Linux CBT SUSE 1. And of course the vacation program responded because it's still in effect. But this tells us that the catch-all is working. So in shell number 3, if we move the arrow key up, you'll see that there's a new message, testing, with the subject testing catch-all address, which shows that the message was originally going to SUSE 2, a non-existing user, and we've caught it. So the message has been sent. This time it wasn't bounced. From Linux CBT Work 1, let's compose yet a new message. We'll send it to a totally different user. Let's send it to spam at linuxcbt.external. Certainly a non-existing user. Testing catch-all again. And we'll send the message, it too has been delivered. We'll clear the screen and re-examine the last lines in the log file. Here's the message. It was originally to spam at linuxcbt.external, got rerouted to linuxcbt SUSE 1 at linuxcbt.internal. Status is sent. It was delivered to the mailbox. The vacation program responded with a reply again because the original from address, the envelope from, is a new address. If the same user, or the user who previously sent a message, attempted to send a message again, then the vacation program would have consulted its database, as it does with all received messages from any sender, that is, and it would have known that it already sent a response to that particular user. So in shell number 3, let's move the arrow key up, and there's the third email, which was originally destined to spam at linuxcbt.external, but was delivered by postfix to Linux CBT SUSE 1 because of the way that we've written the rules. Now let's actually attempt to send a message directly to the user Dean at linuxcbt.external. This will go directly to the user. Testing catch-all, and this will not invoke the catch-all, but we're just testing to ensure that the catch-all will not route it into the user Linux CBT SUSE 1's box. Let's clear screen and take a look at the log file again. And here comes a new message at 12:10 from an unknown client, SASL authentication errors. You can ignore that. We've already looked at SASL. Client unknown. But nonetheless, the message came in from root, and it was originally destined to linuxcbt.external to the user Dean. It was sent to the user Dean, which means in shell number 3, when we move the arrow key up, we won't see any new messages, but in shell number 4, when we launch mutt, there's a new message, testing catch-all. So this didn't use the catch-all rule. It used the direct mapping. So the way postfix works is it'll actually scan the virtual DB, and when it finds a match, especially a specific map, this is actually a specific match rather than the catch-all address, then it'll route it. If it doesn't find a specific match, then it'll rely upon the catch-all address to route the message, of course, to the proper user. Now you can send messages, you can copy additional users, so you can send a message destined to a user to multiple users. So for example, let's nano the virtual file. Maybe you would like to, just like with the aliases file, copy 2 users on this message, perhaps the user Linux CBT SUSE 1 and the user Dean, so that there are 2 recipients defined as catch-all addresses. Simply update the mapping using the postmap utility, postmap virtual. That updates the mapping. And again, notice we haven't restarted postfix. And from Linux CBT Work 1, let's send a message to an address that doesn't exist, at least within the virtual domain. Let's send it to abuse at linuxcbt.external. Subject, testing catch-all to multiple recipients, and we'll send this message. Now in shell number 3, we should see a new message. There it is, testing catch-all to multiple recipients. It was originally destined to abuse at linuxcbt.external, but ended up being delivered to Linux CBT SUSE 1 at linuxcbt.internal. Now in shell number 4 for the user Dean, let's quit this message, and there's the new message, testing catch-all to multiple recipients. And notice that it doesn't reveal that the message was also copied to the user Linux CBT SUSE 1. It simply shows our destination address. You can also reveal the headers. You'll see that it's for abuse, but eventually ultimately got routed into Dean's mailbox. At least that's the way postfix alters the headers when it generates the message. So when it goes through the cleanup process, this is how it's presented. Great, so you can do multiple addresses. Now let's go back to our configuration file. What about routing messages out to a different domain, such as on the internet? That's certainly possible. We can also add additional domains, but since we're working with linuxcbt.external, let's show you how you'd make that change. It's quite simple. Once you have the infrastructure in place, which is basically the two directives, virtual_alias_domains, as well as virtual_alias_maps in your main.cf file, and you've defined your map, then that's all there is to it. So what if we wanted to send messages destined to a given account to an outside user? For example, here is a mapping for the user linuxcbt SUSE1 that we'd like to send to the user linuxcbt SUSE1 here. What if we wanted to map this to the production system on the internet? Easy. We'll just change it. linuxcbt SUSE1 at linuxcomputerbasetraining.com. And now any message destined to our system will be rerouted to the online system, which is actually on the internet. Now we could copy a local account as well by simply separating the right-hand side by commas, which is the standard delimiter, and then both users would get a copy, just like in the third example for the catch-all. Let's try this out. We'll postmap virtual, and then from linuxcbt work1, which is our tertiary system, we'll send a message on to, or send a message to linuxcbt SUSE1 at linuxcbt.external. Testing virtual alias maps to remote user. So now in this example, our SUSE Enterprise box will function for this particular mapping as a pass-through server, because it'll treat the destination address, the receipt to address or recipient address, as a non-local address. Let's send it. And that message has been sent. We'll tail var log mail to see what has transpired at the current time, 12:15. Here comes the message. And as you can see in the last portion, the message, which was originally sent to the user linuxcbt SUSE1 at linuxcbt.external, originally to, was relayed to the internet-based server, mail.linuxcomputerbasetraining.com, internet address. It took a second. It was sent. Here's the DSN message that was returned, and it was accepted for delivery. So what we should do to confirm that it was accepted for delivery is simply in shell number 3, which we're currently logged in as a user linuxcbt SUSE1, we'll purge the messages, and we'll SSH out to mail.linuxcomputerbasetraining.com. And we'll launch the MUD application on the remote system, and there's the new message on March 5th. Testing virtual alias maps to remote user. And you'll see the entire path the message took. This message began at linuxcbt work1, it made it to linuxcbt SUSE-serve1, and then it was forwarded on to the production system, linuxcomputerbasetraining.com. So it made it out to the internet in about a second. We'll purge it. Let's just alter our virtual maps so that we send the message destined to the non-local user to two separate users. So we'll nano virtual. And again, you simply copy the two users, separate them or delimit them using the standard delimiter, which is comma. So linuxcbt SUSE1, comma, the remote user. So a local and a remote user will get a copy of this message. We could also do the same for the catch-all. It's just that it generates so much network traffic that it isn't necessarily worth it. But within your environment, it may be if you're well connected. Let's say 100 base T, gigabit, and so on. We'll compose yet another message to linuxcbt SUSE1 at linuxcbt.external, and we'll see what postfix does with it. Testing virtual alias maps to local and non-local or remote users. We'll send it, and we'll go back to the shell where we'll examine the log file in var log. And let's take a look or examine the transcript. So the message was destined to the user linuxcbtsuzy1 at linuxcbt.internal, which was originally sent to linuxcbt.external, but then postfix turned around and sent the message out to, in addition to the local user, because the vacation program's responding. In addition, it also sent it out to the internet, to the server linuxcomputerbasetraining.com. Now let's take a look at our mailbox locally and remotely. Currently we're logged on to the remote system, and we can simply execute a host name. The host name on this system isn't indicative of or doesn't reflect the canonical domains that are handled by my destination. And in fact, this system is running sendmail, not postfix. In addition, we can execute sbin ifconfig, and it'll tell us that we're logged into a system that's on a subnet that is actually on the internet. It's a 12 address, and it's non-local. So let's launch mutt. There's the message, testing virtual alias maps. And again, postfix has done its job. The message was sent originally to linuxcbt.external, but it got routed. Now in this case, it didn't actually alter the headers. And we'll quit this. And we'll exit mutt. We accidentally hit the A option. Now let's exit the remote system and launch mutt locally, and you'll see also a copy of the same message which was sent. Great. So we'll delete it, and I think you get the picture. So with the virtual table, we can define both local and remote addresses. The advantage to the virtual alias maps is that we can pass through messages that don't necessarily have, or pass through messages for destination addresses which may not necessarily be hosted on our system. So we can function as a pass-through, perhaps as a cleanup or a filtration server. And currently, our email address destined to linuxcbt.external copies a local and a remote user. It can copy multiple remote users if you'd like. That certainly would work out. Great. So next, we're going to look at other things we can do with virtual alias maps, including adding additional domains.